Right, so we're going to look at solving equations. So there's an unknown x, but they're wrapped into logs in some way. So let's go through a few examples, and we'll deal with the issues that come up as we go along. So I've got 2 log base 5 of x equals 7. I think there's a fairly sensible approach here. If I divide through by 2, I get log base 5 of x equals 7 over 2. I would take this method here. Remember in the first video we did this. Go around, so 5 to the power of 7 over 2 equals x. So x is 5 to the power of 7 over 2. And we can, depending on the question, we may be asked to write the answer in decimals, so we'll just do that. So I've got 5 to the power of 3.5, so x equals 280 to 3 significant figures. Okay, next example. So this time I have got an equation that looks like that. So I've got log of 4. Just on this one, I've not specified the base. So by default, the base is 10. So that is if you don't have a base written down, then it is an implied base 10. Okay, so when we get a situation like that, there's more than one log expression in the equation. The approach needs to be to bring all the logs together into a single log. So what I'm looking for is log of something equals something. So these two are going to have to be brought together. So first thing is I want to add, they're adding together, but I've got that 2 there. So my first step is I'm going to use my third rule of logs to take my power up there. Take the power up there. So it's just that's changed. So now I've got a log plus a log. So a log plus a log is the same as the log of the 2 things times together. So brought those 2 together. So now I'm in a nice situation. So now I know that 10 to the power of 2 equals that. So I've got 4x squared equals 100, 10 to the power of 2. So x squared equals 25. Now, there's a little thing we need to just be quite careful of here. So x equals 5 or x equals minus 5. Now let's just think about that. If I was going to pop that back into the equation, put those 2 values back into the equation, and you can do it, you can check it, and you do log of 4 plus 2 times log of 5, and we should get an answer fairly close to 2. If I put minus 5 into there, well, let's do it. Let's do log of 4 plus 2 log of 5. And I've got 2. I've got 2 exactly. So I do the same thing now with, oops, minus 5. What happens? I get an error. And the problem is you can't take a log of a negative value. So actually the answer to that question is x equals 5. Because x equals minus 5 is an invalid solution. So that's something that's worth checking at the end. Okay, last one. So here we go. So I've got something a little bit more complex, but the principles are exactly the same, and your algebra will end up being tested. Sorry, there should be a 3 there. So I've got log base 3 of something minus log base 3 of something equals 2. So I need to bring my logs together. So I'm going to use my second law of logs there. So I'm subtracting the logs, so it ends up being a division within the single log. So I can now unlog it or turn it into index form. So 3 to the power of 2 equals that. I'll write it that way around. 3 to the power of 2. So I've got x plus 11 equals. Top tip, always check it. So we can always put that back into the equation. So we can take, if I can just remember where it is. So if we go from, apologies for taking so long to find that. So if we go, if you want to take log to a certain base, just get rid of all that, sorry. We take the options button on this calculator. This can be a lot easier on a scientific calculator. Might even be worth doing there, where we can, but to do log to a different base on on the graphical calculator is a little bit more difficult, but it can be found like that. So I'm going to put that into the original equation. So I've got 7 plus 11 minus log base 3 of 7 minus 5, and I'm hoping the answer is going to be 2, and it is, and that is correct. And if you do that at the end, then you're absolutely certain whether you've got it right or not. It's also good for checking whether the negatives work. Okay, that's that.